Hello, I'm Jana Peterson. Constructing a building requires many different skills and specialties to do the job the right way. That's why the first step is one of the most important. When it comes to construction, it all begins with the foundation, and carpenters are key with starting the project off right. The pouring of the concrete is actually the last step that finishes the job. But before that, carpenters will measure and lay out where the foundation will go, as well as build forms the concrete will be poured into, much like pouring cake batter into a mold. Today on Built to Last, we'll take a look at the start of all buildings, the foundation.
Built to Last is sponsored by Unico Incorporated, manufacturers of the small duct high-velocity HVAC Unico system. Unico is dedicated to the environment and has been serving residential and commercial customers around the corner and around the globe for more than 25 years.
Great Northern Lumber, providing green construction materials from skyscrapers to residential remodel. Proud to serve you for the last 27 years and into the future in the lumber industry.
There's more to building a foundation than you might have thought. Foundations have two main parts: the footings, or the base of the foundation, and then the walls, which can later become a full basement or a crawl space. Now, the first step is to prepare the ground for the new building, and then also to lay out where the foundation will go according to the blueprints. Next, the forms for the footings are constructed and the concrete is poured. Now, at this point, carpenters will use lasers to make sure that everything is lining up correctly, because this is such an important point of the construction process.
All buildings start with the preparation of the ground at the site of construction. Carpenters will construct the forms that concrete will be poured into, but the operating engineers will dig a hole to the depth required for the basement.
The holes vary between, you got 8-foot basements, 9-foot basements, you know, and you got 10, you got 4, so they all vary. Usually down 6-7 feet, usually, depends.
The specifications for the project all come from the blueprints provided to the contractor. The carpenters will use this information to first set the grade of the foundation. Setting the grade means setting the depth and slope of the foundation to help with water drainage and make sure other utilities, such as the plumbing, will line up correctly to street level once the house is constructed. Carpenters use a laser to set the grade. The laser is placed at the desired height overlooking the site. The foreman uses a grade pole with a laser target on it that is set to the desired height. The foreman then goes around the site with the grade pole and checks the grade at various points. The laser target beeps up or down in the area that needs correcting.
When before the hole gets dug, the surveyors come out and survey where the house is gonna go. And then the excavator digs the hole, and then we come in and we pull off the surveyor's pins to put the house in. And that's, you know, basically those little stakes in the string is us laying the house out, and then we frame it, you know, 5 and 13 or 4 and 12 makes 16. That makes your footing, you know. Our line runs to basically where the house is gonna sit, and then we frame 4 inches to the outside of the line, and then the footing we frame 12 inches on the inside. That gives you your 16 inches, and then we stake it and dig it to the right depth. The stakes give us the grade, and then we shoot the grade, and that's how we get our depth. The footing is basically the base of the house. The hole pretty much starts the house, the base of the house. Yeah, like an 8-foot wall is 16 inches basically. Varies from 16 to 18, depends on the village, to 8 inches deep on an 8-foot wall. 9-foot or 20 by 10. You know, the bigger size your walls go, the bigger size the footings go.
It may take a crew of 3 about 4 hours to form the footings. The foreman then makes a call to a ready-mix plant that will deliver the concrete that will be poured into the footings. The concrete trucks arrive and concrete is poured into the forms. Working together, it becomes a team effort to make sure the concrete is poured correctly and the footings stay in place. Concrete is a versatile material as it can be mixed for different applications.
Hey, you got a summer mix and a winter mix. They put additives for the concrete gets harder, faster. You got different mix for your floors. You got different mix for your walls.
The concrete is finished to grade, then a groove is added in the footing called a keyway.
Kind of locks the house into the footing for like backfilling. Don't push it, locks it in, and plus it vents, helps the water, because water is not basically supposed to go designed to go uphill. So you got your keyway. Basically, main purpose is to lock the wall to the footing.
Carpenters work all year round. At another job site, a different crew removes forms from the footings, and workers prepare to place the drain tile around the perimeter of the footings.
In the winter now, we pour a house, we'll blanket it, and the house will sit 2 days before we'll strip it. We won't strip it right away the next day. Well, drain tile goes around all the living space on a house, or, and pretty much flows the water all to one area to a sub pit that pumps it out, checks it, and it takes all the groundwater and rainwater so you don't get leaks in your foundation, and just keeps it flowing around.
The drain tile will channel all the groundwater that seeps around the foundation to a hole that will later become the sump pump well. Stone gravel will be added on top of the drain tile, and pea gravel will be spread out on the inside areas to help with drainage. With the footings complete, it's time to start building up with the walls.
Okay, this is a laser level. What we do first is the surveyor is going to use it first to establish its excavation, and he's going to read the surveyor's mark or his elevation, and he's going to put it into his calculations, and he's going to dig out the hole for us. This one here is pretty much a self-leveling one that'll spin. It doesn't start spinning until it finds its level. Okay, so you don't have to mess around with the knobs or anything else. Now the benchmark is based on what the surveyors give us. So we're able to read the benchmark, convert it, and then transfer it so then we know the top of the footing. So the guy with the stick or the eye or the receiver, he's going to come inside of the hole and find the top of the footing. That right there tells me that the bottom of the stick is the height of the footing. But now you got to figure out the top of the wall. And that goes back to the surveyor's mark. And you got to do some math, and you got to put it into your receiver again. Then, after you're done setting your elevations, which is probably anywhere from 15 to 20 feet, pound some nails, 4-penny nails, 6-penny nails, snap a line, snap line. That'll give you a nice straight line. Probably you're going to pound some 4 pennies or 6 pennies again every 2 feet. That way, when you pour the concrete into the foundation, you got the float man or the guy that's floating up the wall. He's going to strike it off right to the nails. He's going to give you a nice level foundation. Now this other instrument we have here is transit level. A lot like the laser, but this is a 2-man operation. Okay, this is not a self-leveling, so you actually got to lock everything in place. Make sure this is level. So you got to fine-tune it here. And this will shoot, depending on the model, it'll shoot anywhere from 100 feet to 150, and they got different models that go a little further away. Once you start getting a little further away, then you lose a little bit more accuracy. There's going to be another worker with his ruler or tape measure. He's walking over to the surveyor's point, and the surveyors are going to give us a point where we got to follow. Once we got that number, we got to translate it, we got to mathematically convert it, and whatever measurement we come up with, that's going to be the top of our footing or the top of the wall. Once we have our foundation wall framed up, there's a guy holding the ruler, and he's going to tell me what number he's looking for, and then he's going to tell me either up or down until he finds the number that we figured out, and he's going to lock in. He's going to tell me, okay, mark it, and I will mark the bottom of the tape or the bottom of the ruler. That'll give me the top of the foundation or top of the footing. This is basically the same thing as a laser, except for our transit is the two-man operation. That's why we are going more and more. You're going to see this more often, especially on commercial jobs. On residential, you might see these once in a while, but on commercial, you're going to see nothing but lasers.
For laying out a piece of property to locate a building, to locate a house, we would set up what we call batter boards and extend dry lines and use tapes and use builder's levels in order to be able to make sure that we can locate the building properly and lay it out square. Now there's new technology called the total station, and the total station, I don't want to say eliminates all of the four items that I just mentioned, the tape measure, the plumb bob, the builder's level, and the dry line, but incorporates it all into one electronic instrument.
The total station is a lot more sophisticated. It takes more time to input all of our data into our data collector. From our print, we take our numbers, we convert them, then we'll put them into our data collector. Now the data collector communicates with the brain, and the brain tells us what degree to turn, what's the distance we got to turn to get a certain point. So I can actually set this at one point and lay out a whole building from a certain point, as long as I can give the right data to the instrument.
In this room, we have a table. The table has corners. The corners are located somewhere in this room, correct? So a building is located somewhere on the job site. And that somewhere is input into a data collector, which is then uploaded into a total station for laying out. And it just eliminates so much of the old-fashioned, let's pull a tape, let's get a dry line, let's get a builder's level. And just combines all of that technology into one.
All right, so what happens is the total station will send a laser to this peanut. It'll ricochet back to the instrument. It'll tell me exactly the distance that I have from the instrument to wherever I'm holding it. Now, if you're using a prism this small here, if you got this set on the ground, if you're shooting down on an angle here, the total station will take that hypotenuse or the diagonal and it'll convert it into a horizontal measurement. That way it's not giving me the actual horizontal measurement, it's giving me the horizontal measurement, this one, not the diagonal measurement.
Although the product itself is sophisticated, carpenters run the machine on the job. And we can perform the job that used to take several hours in much less time.
After the concrete for the footings has dried, the footing forms can be removed and the drain tile and the sump pump well can be installed. Now the carpenters at this point will begin construction on the foundation walls, and they'll use large reusable forms for these walls. Now at this point, rebar will also be added to give the concrete some extra strength. Once again, the carpenters will use a laser to make sure that the concrete walls are the correct height and the foundation is level.
Constructing the walls of a foundation follows the same basic process as building the footings. Forms are erected to hold the concrete as it gets poured. Then after drying, they're removed. There are various systems of these forms, from just scratch plywood to styrofoam insulated ones. These carpenters are using reusable forms that can be used again on different projects. With wall forms, ties are inserted to hold the form together to support the pressure of the concrete pushing against them.
When we're framing the wall, the ties lock the form together, so when we pour, they hold the true 8 inches for an 8-foot wall.
There are many types of wall ties that are used for all sorts of forming applications and systems. Once the form is removed, called stripping, the wall tie is addressed according to the manufacturer's specs. Concrete is a very heavy material, so extra support called kickers are added to keep the forms from falling over due to the weight of the concrete. Concrete is a very brittle material and can withstand great vertical loads in the form of compression, but it is fairly weak when it comes to tensile strength, which is the amount of load a material can handle while being stretched. Support for tensile strength comes in the form of an interior steel skeleton that is added in the form building process known as rebar. Rebar is a steel reinforcing bar that is added to the inside of the form so the concrete surrounds it when poured.
Some people get an 8-foot foundation, or some people want a 9-foot foundation, and that varies your wall height.
Carpenters will need to access the top of the forms to help with the pouring of the concrete. Temporary scaffolding is constructed using wall brackets and planks. This allows the carpenters to walk around the perimeter of the foundation. Every home foundation requires that an access window be installed large enough to act as an escape in case of an emergency.
We start framing a wall, and where a window goes, you frame one side, and then you measure up whatever that measurement is, usually around 36, 37 inches up from the footing, and then you just basically nail them into the form, and then when you strip, they stay into the wall.
Ahí son 22-1. Regrésala 13 pulgadas para atrás.
Once the forms are up, the carpenters will line the walls using dry lines to assure they're straight, then lay out the finish height of the concrete. Using the laser and target, the foreman walks around the forms and locates the exact height, makes a pencil mark, and snaps a chalk line for grade. When the concrete gets poured into the forms, they'll be filled to this chalk line. This determines the actual height of the walls in certain places of the foundation that is required by the blueprints. The concrete trucks arrive and the carpenters do some last-minute preparation.
Test form oil. So you spray on the forms. That helps the forms to come off easier the next day.
The carpenters help place the concrete to where it needs to go and periodically rod the concrete. This technique vibrates or shakes and helps get rid of any air bubbles that may be trapped. The idea is to have a smooth finish on the walls. Once the forms are to the finished grade, the top is finished flat and smooth and allowed the proper time to dry and cure.
It's a new system. It's basically all styrofoam. It has a tie system built in that you can connect rebar to. It has 2 cores of styrofoam, 2.5 inches of styrofoam on the outside, 2 on the inside.
You can pour your foundation, you can pour your first floor with ICFs, even your second floor. You can even go up to the roof and pour your trusses all concrete. Now these are great for cold weather climates. These are great for tornado valleys, maybe like a hurricane, places like Florida.
The components that go inside the wall here, as far as framing it up, depending on the specifications, whether it's in our area or any area in the country, you have to find out what the building codes are in that particular area. They're going to tell you how far apart the horizontal steel they want it. They're going to tell you how far apart the vertical steel they want it. You can do it yourself. It's just like putting a big Lego system together. But you have to follow the specifications for that manufacturer. And it may stipulate 1/2-inch bar, it may stipulate 5/8 bar, it may stipulate 3/4 bar. Whatever it stipulates, that's what you're going to follow.
The nice thing about these forms is that you can screw your siding to it, you can screw your drywall to it, so there's really no frame in the perimeter of the house. It's just the interior partitions that got to be framed out, whether it's wood or metal.
Now, when the concrete mix itself is a special design mix. That mix, you can't use standard concrete. They might enrich the concrete to a higher cement ratio and a smaller aggregate size. Below grade, we can put some type of damp-proofing agent on it that will not melt the styrofoam. It has to be something like ball clay, or it has to be a latex so that it doesn't melt the styrofoam.
As far as the energy, you got insulation that stays in place. You don't take that out. So you backfill with the insulation in there. So you got insulation outside of the house, so you got insulation inside. So you got the R value is incredible for the ICFs.
Now, like typically any house or building, we have penetrations that go through the wall. Piping, plumbing, electrical. Well, we can work with the other trades if our contractor wants us to, or it's a system that's designed, if they give us the parts, we can put it in. Can this application be done on a commercial building? Yes, it can. You're just following whatever the codes are, the specs for the building department in that particular area.
You're going to save a lot of money in the long run for your heating and air conditioning. No air infiltration through any of the plates, the top plate or even the bottom plate, because it's all one solid wall going up to the first or second floor. That's why more people are going to the ICFs, because of the technology that they bring, which is the green technology.
After the concrete is dried, the forms can be removed, and then the final prep work can take place to finish off the foundation. This includes adding the window wells, adding the tar to seal off where water might come in, and then putting the gravel around the perimeter to finish off the work on the drain tile.
Construction takes place in all seasons, and at this site, the forms are ready to be removed and final work on the foundation can begin. These concrete forms are reusable, so the carpenters remove them and stack them, while a boom truck picks up a group of forms and loads them on a truck that will take them to another job site. The foundation window is below ground level, so a heavy gauge galvanized steel well is installed on the outside of the window. So when the foundation is backfilled, the window will still be able to let light in and provide access from the basement. Window wells prevent unwanted soil from entering the basement and allow the window to operate. After the forms are removed, the ties that held them together stay in the concrete. The tie ends are hammered off and tar is applied over the tie holes to protect the foundation on the soil side. The window wells also get a splash of tar to help with water problems. Other crew members focus on smaller details, such as adding gravel to the drain tile and cleaning up around the foundation. One of the final steps is damp-proofing the exterior walls of the foundation. A damp-proofing solution will be sprayed on the walls with a chemical that will act as a moisture barrier for the concrete. The concrete takes about 28 days to cure, meaning it has reached its full strength. Finally, the floor is poured and the foundation is complete. But the work of the carpenter has just begun.
For most projects, the construction of a foundation follows the same basic steps. The area needs to be laid out and forms have to be built. Now, simple as that may sound, getting this part of the construction process done correctly will help to ensure that the rest of the project will fall into place. From here, it's a race to get the roof on and the sides sealed up so that the interior parts can begin. I'm Jana Peterson. Thanks for watching, and I'll see you next time on Built to Last.
Visit the Built to Last website to learn about these topics and more.
Built to Last is sponsored by Unico Incorporated, manufacturers of the small duct high-velocity HVAC Unico system. Unico is dedicated to the environment and has been serving residential and commercial customers around the corner and around the globe for more than 25 years.
Great Northern Lumber, providing green construction materials from skyscrapers to residential remodel. Proud to serve you for the last 27 years and into the future in the lumber industry.